Hi students! In this video we're going to be going over some of the 9A common homework problems that have to do with quadratics written in standard form. So standard form looks like this. Instead of having our quadratic written out in like x squared plus 3x plus 2, we'll have a form that has parentheses in it. It might have a coefficient out front, and then it's going to have our constant in the back. And we'll do some examples to show you how exactly we can go from one form to another. But I want to point out a few things about this form specifically. The first one is, since we've already talked about transformations, you know what some of these pieces, A, B, and C, do. A, as a constant out front, is going to represent a stretch or a condensing, depending on whether it's a number bigger than 1 or less than 1. And also, depending on whether A is positive or negative, it could represent a flip as well. A negative A would represent a flip over the x-axis. B represents a horizontal shift. Now remember, when it's inside the parentheses, negative means right and positive means left. And then finally, C represents a vertical shift, up or down, where, since it's outside of the parentheses, a negative is going to mean down, just like you would expect, and a positive is going to mean up, just like you would expect. So because of the two shifts, the horizontal shift and the vertical shift, this standard form actually gives us a shortcut to the vertex. The vertex is going to be located at the x value and the y value of negative b, comma, c. Now it's negative b because our b inside the parentheses is going to be the opposite sign of what we'd expect, whereas the c outside of the parentheses is going to be exactly what we would expect. So we have to flip the sign for b, but we don't flip the sign for c. And this is a little shortcut that will help us easily find the vertex when we have standard form. So in order to get a quadratic function into standard form, we use a process called completing the square. And we'll demonstrate that with some examples that are coming up. So question 8 from the common version of homework A gives us a quadratic function and asks us to write it in standard form. And of course, you'll recognize A times the quantity x plus b squared plus c, which is exactly what I was just talking about. That's our standard form. So let me show you how we go from one to another. We're going to use a process called completing the square, where first we rewrite our function. And we take our first two terms, the terms that contain the x's, and we factor out any number from our first term like this. So from the 3x squared and from the negative 24x, I factor out a 3 and move it out front. But then we still have this plus 53 inside. So the first thing we do is factor out a common factor from our first two terms. And then I'm going to rewrite my function and leave some spaces. So I'm not changing anything right now. I'm just going to leave a little bit of space inside my parentheses, and then I'm going to leave some space outside my parentheses to make a couple of changes. This next part is actually called completing the square. We want the inside of parentheses piece to be a perfect square. So we're going to try to put something in this blank that makes what's in parentheses a perfect square. And I think you guys have already gone over this in your class, but if not, you're about to learn something new. So the stuff that's in parentheses, I'm going to write it in red right now. We want it to be able to factor into a perfect square. Well, if it's a perfect square, then this piece and this piece have to be exactly the same. So that would look like, x minus something and x minus something, where these two blanks are filled with the exact same number. Now, if we were to multiply these two things back out or FOIL them, they have to equal this thing we started with. So the number I need to use here in both of these blanks, is 4. And let me explain why. If I were to take this and multiply it back out, I would get x squared minus 4x minus 4x plus 16. Well, the minus 4 and minus 4x both combine to give us minus 8x. So this is x squared minus 8x plus 16. This right here is what we started with. So I knew I needed to use -4 and -4 because they multiply together, or they add together, to give me -8. So essentially, the number we're going to be filling into that blank for our perfect square is half of this middle value. So I took -8, I divided it by 2, and that's where we got the -4 and the -4. So what does that tell me about this blank right here? Well, when I multiplied them together and I did my foiling, I guess I shouldn't have erased that. When I multiply the -4 times the -4, I get positive 16. So what we fill into the blank here needs to be a plus 16. Now you might be wondering about the second blank here on the outside. When I filled my first blank with a positive 16, it's not actually just a positive 16. I also have this 3 out front that gets multiplied to the positive 16. So by adding in this 16, what I've really done is added in 48. Well, we're not allowed to just add 48 into our equation with no consequences. If you add 48, you have to offset it by also subtracting 48 as well. So we've added 48, we've subtracted 48, and by virtue of doing both of those things, we technically haven't changed our equation. And this is the process of completing the square. I'm going to erase some of my scratch work here. We now have a plus 53 and a minus 48 as well. So notice, since these can now be factored into x minus 4 times x minus 4, I can rewrite this as 3 times x minus 4 squared, and then I can combine my positive 53 and my negative 48 into a simple plus 5. So I have completed the square. I now can very easily look at my function and find my a, my b, and my c, and I can fill in my answers as 3, -4, and 5. So now the question remains, what is my vertex? Well, the vertex is equal to -b, c. And since b is -4, then -4 and c is 5, that will give me +4, 5 as my answer. Goodness. For my vertex. So +4, +5 goes right here and here as the vertex. So we're going to do plenty more examples like this. If that example was confusing, just hang tight. They might get a little more clear. Question 15 has us kind of going in the other direction. We have a parabola and they're giving us the vertex. They're also giving us a second point, and they want us to find our equation but in this form. So we're going to use the information we have to fill in. Oh, they didn't give us f of x, they gave us y. So let's write this. Y equals blank times x plus blank squared plus blank. Okay, so I'm struggling here to write this out with blanks because they gave us capital A, capital B, capital C here, which is typically how we would, the variables we would use in standard form, but since they used A, B, and C already, I'm going to have to use, how about D, E, and f. So given the new form, the new standard form I just wrote out with these variables, our vertex should be negative e, comma, f. Well, they've told us that our vertex is negative 4, comma 5. So if the vertex is negative 4, comma 5, notice the 4 is already negative, so e is just equal to 4, and f is equal to 5. So I can go ahead and take my standard form and write in x plus 4 squared and plus 5 at the end, just from the e and the f that they basically handed to us by giving us the vertex. The only thing left is now I have to figure out what d is. Well, in order to do that, I'm going to have to use the other piece of information they gave us in the problem. Our equation contains the point negative 5, comma 4. So negative 5 here would be an x value, and 4 would be a y value. So I can use that in this equation to figure out what d is. So if I take 4 and plug it in for y, equals d times, and then take negative 5 and plug it in for x, I'm going to be able to solve for d. So that would give me d times negative 1 squared, which is negative 1 squared will give me positive 1, so that'll just be d plus 5. And then to isolate d, we subtract 5 from both sides. So you end up with d equals negative 1. So if d is negative 1, then y equals negative 1 times x plus 4 squared plus 5. So great, we have our quadratic written in standard form, but that's not what they want. They don't ask us for standard form, they ask us for this form with everything all multiplied out. So I'm going to have to actually multiply out the quadratic. So that's going to require foiling x plus 4 squared. So we'll rewrite it as negative 1 times x plus 4 times x plus 4, and then we FOIL. I don't know why this keeps happening. There we go. So that'll be negative 1 times the quantity x squared plus 4x plus 16. And we're going to need to distribute the negative 1 through the parentheses. So that'll be negative x squared minus 8x minus 16 plus 5. And finally, we can combine the positive 16 or the negative 16 and the positive 5. Now we have our quadratic written in the form they've asked for. So just looking at this, we can tell that a is negative 1. I know it's not written there, but there's a 1 here. So a is negative 1, b is negative 8, and c is negative 11. Most of that was just simplifying things down. The meat of the problem occurred here in red and green. The rest of it was just some basic algebra to get things in the form we needed. Okay, for question 23 from the common version of the homework, we are given a quadratic form, or a quadratic function, and we would like to rewrite it in standard form. So in order to do that, we're going to have to complete the square. So I'm going to come down here to the bottom. Let's just ignore some of this other stuff for now. I'm going to come down to the bottom and rewrite my function, g of x equals negative 3 times x squared minus 6x minus 24. Notice as I rewrote it, I factored my first two terms. I pulled out the common factor of negative 3. That's because inside of our parentheses, we want our first term to be just a plain old x squared without any constant in front of it. So now in order to complete the square, I'm going to need to give myself more space to work with. So we'll rewrite this with a little bit of space. And I'm going to try to fill in this blank and this blank with two numbers that offset each other, so they can't actually change our equation. We need them to cancel each other out. But we're going to do that in order to turn this into a perfect square. So if it's going to be a perfect square, it needs to be able to be written in a form like this, where both sets of parentheses are the same. So to factor this, we would need an x here and an x here. And now we need two numbers that add together to give us -6, but they both have to be the same. So all we're really doing is cutting -6 in half. So that would be -3, -3. So if we were to FOIL this back out, and this is just scratch work, we'd get x squared minus 3x plus 9, which is x squared minus 6x plus 9. So comparing this to this step right here, the number we need to fill into that blank, the number that we're adding into our equation, is a +9. That comes from right here. So it's not just a +9. Keep in mind that there's this -3 out front, that if we multiply this back in, that would turn that 9 into a -27. So really what we're putting into our equation here is a -27. So we need to offset that by adding a +27 on the outside. So now I'm going to erase some of my scratch work. What I'll do for the next step is condense this a little bit. So we have a x minus 3 times x minus 3. We can rewrite that as x minus 3 squared. And we have a -24 and a +27 that we can rewrite as +3. This is our standard form. So here's my A, here's my B, and here's my C. The next question asks us to identify the concavity of the parabola. Well, it actually doesn't require standard form to be able to tell the answer to this one. All you have to do is look at your leading term. If it's positive, it's concave up. If it's negative, it's concave down. So here we're looking at a -3x squared. You can also look at this number right here, your A. If your A is negative, it's concave down. So we've got down as our answer here. To identify the vertex of G, we're looking for -b, C. So let's go back down. Our B is -3, so our vertex is +3 and then comma +3. So you have to change your sign of B, but you don't have to change the sign of C. So that'll give us the vertex of 3, 3. And then the axis of symmetry is pretty simple. Your axis of symmetry is going to line up with the x value of your vertex. That's because if your vertex is at 3, 3, your axis of symmetry goes right down through it. So that would be the x value of +3, which comes from the +3 of the x value of your vertex. Now they're asking for zeros. They're asking for the zeros of the function. So we can solve this in two different ways. We could start from the original equation that we were given, which is up here at the top, set that equal to 0. So here's our original equation. We could set it equal to 0, factor it, and then solve for x. Or we can use our standard form to do the same thing. So we would be setting it equal to 0 and solving for x. And I personally think that this method is a little bit easier because when it's already in standard form, it's essentially already factored for you, so the steps are a little bit easier. So in order to solve for x, we're going to first have to subtract this 3 to the other side. So that's going to give us -3 times x minus 3 squared equals -3. Then, to get rid of this other -3, we're going to divide both sides by -3. So that'll leave us with x minus 3. My pen colors aren't changing. X minus 3 squared equals +1. Then the next thing we need to get rid of is the square. So we're going to take the square root of both sides. Whenever you take the square root of both sides, you get the positive and the negative. So we end up with, on the left-hand side, our square root and our square cancel each other out, so we'll just have x minus 3. On the right, we end up with plus or minus square root of 1. And the square root of 1 is just 1, so I'm actually going to erase this, and we have plus or minus 1. Now finally, to get that x by itself, we add 3. We add 3 to both sides, so we end up with x equals positive 3 plus or minus 1. Now this is technically two solutions. It's 3 plus 1 and 3 minus 1, so these are actually going to be 4 and 2. So x equals 4, x equals 2, which we would fill in here. Now they want to know the y-intercept. And of everything we've done so far in this problem, the y-intercept is the easiest thing to find. In order to find the y-intercept of any function, all you have to do is I'm trying to write here, but my pen's not working. Let x be 0, find y. So for this one, I'm going to use my original equation. In the original equation, if we let x be 0, this goes away, and we're just left with negative 24. So your y-intercept is always just the constant that's kind of added at the end. Notice, however, from standard form, that's not what we have here. We don't have a negative 24. That's because this value, after you square the 3 inside the parentheses and then multiply it times the 3 outside of the parentheses, that will be a constant as well, so it gets added in or subtracted in with the other plus 3. So to find your y-intercept, it's always easiest to look at the equation written in this form. Finally, you're going to use all the information we've talked about to pick the right picture. And so we're going to need a concave down parabola, so that eliminates this one right off the bat. Our parabola has to have a vertex of 3, 3, so that eliminates this one and this one, leaving us with only b. Okay, that was a lengthy problem, and I think our next one is very similar to that one. Yeah, in fact it is. So in question 9, from the common version of the homework, we're doing basically the exact same process. We're starting off with a parabola, and we need to convert it into standard form by completing the square. So I'm going to rewrite the equation, h of x, but then notice that this is a 4x squared, so I'm going to factor out a 4 to the front of this from the x squared term and from the negative 8x term. So my parabola, or my equation, now looks like this. I'm going to rewrite it to leave some space. So I'm going to put a blank inside the parentheses and another blank outside the parentheses. Now we're going to complete the square in order to turn this into a perfect square. So if it's a perfect square, it can be rewritten in this form, where the two sets of parentheses are exactly the same. So it would factor with an x and an x, and we need something that adds together to give us negative 2, and the two things have to be exactly the same. So what we're looking at doing is just taking the negative 2 and splitting it in half. So what we need here is a negative 1 and a negative 1. If I were to multiply this back out, it would give me x squared minus x plus 1, which is x squared minus 2x plus 1. So we got what we needed. Notice that it's a plus 1 that we need to add in here to make this a perfect square. Well, if it's a plus 1 that we add in parentheses, this 4 would multiply by the 1, making it a positive 4. So in order to offset the plus 4 that we just threw in here, we're going to need to throw a minus 4 on the outside of the parentheses. So erasing some scratch work. Trying to. My pen ever works. And we're going to rewrite this as 4 times x minus 1 squared plus 1. This is my standard form. So I can actually gain a lot of information from this form. I can find my a, trying to write that in red, my b, and my c, which gives me information about the vertex, the axis of symmetry, things like that. So let's go back and look at our questions. Identify the concavity of the parabola. Well, we really only need to look at the first term here. Positive 4x squared is going to give us a positive or upward concavity. The vertex depends on b and c. So since b is negative 1, we switch our sign to get positive 1, and c is positive 1. We leave that sign the same. Our vertex is 1, 1. Then the axis of symmetry is going to track with the x value of our vertex. And now it's time to find the zeros. So we could find the zeros by taking our original equation, setting it equal to 0, and solving for x. But that's going to either require factoring, or if factoring doesn't work, we'll have to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you've done that enough times by now to know that that gets ugly. So I'd rather avoid that if I can. Since we have this standard form so nicely at our disposal down here, let's solve for x using our standard form. So we start out by setting our parabola equal to 0. So 4 times x minus 1 squared plus 1 equals 0. So we always set it equal to 0, regardless of what method we're using. But here, this one's going to be pretty easy to solve because we just have to manipulate it using some algebra. Let's subtract 1 from both sides. That's going to give us a negative 1. Now we'll divide both sides by 4, leaving us with an x minus 1 squared on the left and a negative 1/4 on the right. Now, to get rid of the square that's on the left, we're going to take the square root of both sides. Remember, whenever you do that, you get the positive and the negative root. Our root and our square on the left cancel. So we'll have x minus 1 on the left equals plus or minus the square root of negative 1/4. So there are a few ways that we can simplify this. First of all, the square root of a negative means that we can move the negative to the outside and it becomes an I. So I'm going to get rid of the negative, whoops, and throw an I outside. Next, we can actually simplify the square root of 1/4. The square root of 1/4 is just 1/2 because 1/2 times 1/2 is equal to 1/4. So this becomes x minus 1 equals plus or minus 1/2 I. And then finally, to get that x completely by itself, we add 1 to both sides. So we would rewrite our solution as x equals 1 plus or minus 1/2 I. So this is two answers. It's 1 plus 1/2 I, and it's 1 minus 1/2 I. So you would type your solution in as two separate answers separated by a comma. Now, the way I wrote the answer in here simplifies it down a little bit. It combines our two separate terms into a single fraction, but I shouldn't say this because I don't know web class very well yet, but you might be able to input your answer the way I've written it down here. If not, all you have to do is find a common denominator. So you would multiply your 1 by 2 over 2, find a common denominator, combine it that way. I'm not sure if they would accept this form or not. So you might have to play around with it to get it into a form that web class likes. Okay, I think our last question, nope, y-intercept. So we talked about the y-intercept before. The y-intercept is really easy. It's right here. The y-intercept is what you get when you let x be 0. So these two things would just disappear and you'd be left over with a positive 5. So there's our y-intercept. And finally, we want to use all the information we've gathered to choose a graph that matches that information. So the first thing we know is that it's concave up. That's going to eliminate this. The next thing we know is that the vertex is at 1, 1. So that eliminates this one and this one, leaving us just with C. Okay, I think we just have one more problem to do, so I'll try to get through this relatively quickly. We have a quadratic function here, g of x. They want us to identify the following characteristics. First of all, we need to write it in standard form. We'll do that in a second. Let's talk about b. They want to know if what parent function g is built out of. And of course, this is an x squared, a parabola, so our parent function is x squared. The third thing they want to know, let's go ahead and do that one as well. The third thing they want to know is the concavity. And for the concavity, we're still going to look at the first term, that positive 2x squared. Since it's positive, we're concave up. So a concave up parabola is going to look like this. Notice that my endpoints they go on forever, right? That's not the end. They keep going. So a concave parabola is going to keep going up in both directions forever. So D is pretty easy to answer as well. As x approaches negative infinity, which means as we look left on the graph, y is going to be approaching positive infinity because it's going up forever. As x approaches positive infinity, which means as we look right on the graph, y is going to approach positive infinity. Basically, in a concave up parabola, y is always approaching positive infinity. Both sides, since it's concave up, are going to be going up to infinity forever. So another easy problem for us to answer. The rest of these problems will be easier to answer once we get this into standard form. So we're going to go ahead and do standard form, and then we'll answer E through K. So let me get this copied down. We've got g of x equals 2x squared minus 16x plus 27. Okay, I'm going to make some space here. The first thing we need to do is load the problem. The second thing we need to do is factor out the 2 from our first two terms. So we're going to pull a 2 out front, which will leave us with an x squared minus 8x. And then we're also going to leave a blank inside those parentheses. And we'll put a counteracting blank on the outside. We need these two blanks to completely undo each other or counteract each other. So inside the parentheses now, let's complete the square. To complete the square here, we need to fill the blank in with something that's going to let us factor this into the same thing twice. Basically, we're just going to take that negative 8 and we're going to split it in half. So we'll put a minus 4 here and a minus 4 here. Those were both supposed to be red. When we do that, if we actually multiply these parentheses back out, that would give us x squared minus 4x plus 16, which is x squared minus 8x plus 16. So we got the x squared and the minus 8x that we started with, but we have this this positive 16 that we need to put on the blank. So remember, we have to counteract the 16 that we're adding in, but you might have to pay close attention to these because this isn't just a 16. The 16 would get multiplied by that 2. So in fact, it wasn't a 16 we added in, it was a positive 32. So to counteract that, we need to subtract 32 on the blank on the outside. For our next step, we're just going to rewrite this in standard form. The x minus 4 times x minus 4 can be rewritten as x minus 4 squared. And outside of the parentheses, we can add those two numbers together, simplify them down to negative 5. So this is our standard form. They don't have us type that in anywhere. Oh wait, that was part A. They wanted us to type our answer in as standard form, so that's what I've written here. And then part E asks us to identify the vertex. Well, the vertex, we just flip this sign and carry this down, so it'll be +4, +5. That's our vertex. Or -5, I'm sorry. We don't need to flip that sign. Then the axis of symmetry tracks with the x value of the vertex, so it's just x equals 4. And then we want to find the roots or zeros of the function. So that's going to require us taking our function, g of x, and I'm going to leave it in standard form, setting it equal to 0 and solving for x. So let's add 5 to both sides. Divide both sides by 2. The 5/2 doesn't simplify. And then we'll take the square root of both sides. Remember, when you do this, you get the plus and the minus. So we'll get x minus 4 equals plus or minus square root of 5/2. And then finally, we need to add 4 to both sides to get that x completely by itself. So we have x equals 4 plus or minus the square root of 5/2. So this is two separate answers, 4 plus the square root of 5/2 and 4 minus the square root of 5/2. And that's what I've written right here. The y-intercept is really easy for us to identify. You just go right back up to your original equation. The y-intercept is when x would be 0. So these would go away and you would just be left with +27. Now they're asking us to identify a maximum or a minimum. This is a trick question. They've already asked you about that. The max or the min is the exact same thing as the vertex. So all you have to do is take this 4, -5, copy it down. They don't even tell you to identify whether it's a max or whether it's a min. They just ask you to basically copy down the vertex. The domain of any parabola is always -∞ to infinity. That's because parabolas always go all the way left and all the way right forever. So it includes every single x value in both directions. The range, however, is trickier. If you're dealing with a concave up parabola, our range is going to start here and will include everything up to +∞. So we'll have a bracket, the y value of our vertex, and then all the way to +∞. So that's why we have a square bracket and from -5 to infinity. Just imagine for a moment we had a negative parabola for a second, or a concave down parabola. In this case, your range would include everything from your vertex down. So we would start at -∞, count up to whatever the y value is of our vertex, which we wouldn't know. We'd need an actual problem, and then a square bracket because that would be included. So just something to keep in mind in case your problem on your homework, your personal version, is a downward facing parabola, your range is going to look quite a bit different. And that's the last example we wanted to do. I know this was a long video, but we didn't have class today, so you've had plenty of time to watch it. So now you have enough information from the last two videos, this one and the one that we recorded yesterday. You should have enough information to do any problem on the homework that has to do with a quadratic function. So good luck on your homework and send me an email if you're having any questions or any trouble with your problems.